Unit 11A, confidence intervals for mu when sigma is known. Here's an example. A random sample of 50 New York City police officers has mean weight of 170 pounds. From previous studies, the standard deviation was found to be 20 pounds. Find a 95% confidence interval for the mean weight of all New York City police officers. It might be helpful to make a diagram to summarize the problem. The population we're interested in is all New York City police officers. The parameter of interest is mu, the population mean, the mean salary of all those officers. We'd like to know something about mu. The way we're going to do it is we're going to use inferential statistics. We're going to take a sample of New York City police officers. Now, the sample size is 50. The sample had a mean, X bar, of 170 pounds. And in order to do any kind of problem, inferential problem involving means, we're going to need a measure of variability. And that's either going to be the standard deviation of the population or standard deviation of the sample. Now, in this case, it says from previous studies, the standard deviation was 20 pounds. Well, this is not from our sample. So it's not from our sample, so we don't use S, and we use the 20 pounds as an estimate for the population standard deviation. We're looking for a 95% confidence interval, so let me record that. A picture summarizes what I did on the previous slide, and the first step in getting the confidence interval is to calculate the margin of error. So we substitute into the formula margin of error E is equal to sigma times Z critical divided by the square root of the sample size. So E is equal to, sigma is 20 over the square root of N is 50, times on top Z critical. Now, how do we get Z critical? There are a few ways of getting Z critical. I'll show you 3 ways. The easiest way is to use a chart like this, and you merely look up the confidence level, 95%, and it tells you Z critical is 1.96. That's the simplest way. Another way to do it is use the standard normal distribution chart. To do that, you have to first make a picture. And remember that we're talking about a 95% confidence interval, and we want to know what Z critical is going to be, this number here. If in the center we have 95% of the scores, that leaves 5%, so each tail is 2.5%. So the area below Z critical would be 95 plus 2.5, or 97.5%, or as decimal, 0.97 Well, that's the area below Z critical. So now we go into the normal distribution table, and in the body of the table is here, this part, those are the areas below particular Z-score. We're looking for the closest one to 0.975. Well, here it is right there. There is 0.975. That's the area we want. What is the corresponding Z-score? 1.96. 1.96. A third way for finding a Z-critical is to use the TI-84. You would press second distribution, number 3, inverse norm, and same picture as before. Z-critical has an area below of 0.975, so depending on how new your calculator is, the new ones have a menu where you put in the area below 0.975. The default settings are 0 and 1 for a Z-curve. The mean of a Z-curve is 0, and the standard deviation is 1. And then you go to paste, and when you hit enter, you'll get this line, and hit enter again, and you'll see you'll get a much more accurate value of Z-critical, but if you round it off, it comes out to be the same as the others. We got 1.96. Well, back to our margin of error. Now that we know how to get the margin of error, we plug 1.96 into the formula for the margin of error, and we do the computation. In the numerator, we'll get 39.2 over the square root of 50 is 7.071, so on. And this is going to be approximately 5.543 and so on. And since X bar was 170 pounds, we usually carry 1 decimal place more than X bar for the margin of error. So since X bar had no decimal places, we'll carry 1 decimal place for E, and since 4 is small, we'll use 5.5 pounds as the margin of error. Well, once you have the margin of error, it's very easy to get the confidence interval. There are 2 different formulas. The first one, the classical formula, says that mu is between X bar, which was 170, plus or minus the margin of error 5.5. That says that mu is between 164.5 pounds and 175.5 pounds. That's the 95% confidence interval for the mean weight of all New York City police officers. Or sometimes this other formula is used. Mu equals X bar, 170 pounds, plus or minus the margin of error. So we would say that the mean weight of all New York City police officers is 170 pounds plus or minus 5.5 pounds, or you could say 170 pounds with a margin of error of 5.5 pounds. You could also use a calculator to find the confidence interval. If you have the TI 84, you do stat tests, and then you go to number 7, the Z interval. You'll see a screen where you have to input, first of all, you have to input either data or statistics. Inputting data means you would actually put into list 1 the 50 weights of the policemen in our sample. You would enter the 50 scores. We don't have that. We have the summary statistics. So you would first have to go to statistics, hit enter, and then you would just fill in all these items that are required. The standard deviation 20, the mean, sample mean 170, sample size 50, confidence level 0.95, and then you press calculate, and you'll get the confidence interval in this form, which is 164, if I round it off, 0.5 to 175.5. So it's written in a slightly different way, but it's really the same numbers we had before.